All right, welcome to our next Nios tutorial / demonstration video. Today we are going to be implementing a Nios II softcore processor, and we are going to be using the D10 standard board that has 64 megs of onboard SD RAM that we're going to use. And then we're going to run FreeRTOS on that Nios II softcore processor. So we'll be going through that process today. One word of warning, Intel FPGA has deprecated the SDRAM controller for this board and the IP, so you have to use an older version. You can also install an older version and bring that IP forward into the new version. That's what I ended up doing. So let's get started. Like always, we will start out with FreeRTOS, and we'll start with a new project wizard. All right, we will go and let's put this in my D drive. I've got my video demo folder, and I'm just going to do a new folder in here. And we'll call this Nios FreeRTOS. So we'll put it in there, and that's what we'll call our project. We are a 5CSX FC6D6 F31C6 chip. And I'm not planning on simulating, but we'll go ahead and choose a simulator. Okay, our project is created, so we'll go ahead and fire up Platform Designer. All right, Platform Designer is up, so we'll go ahead and give ourselves some room. And of course, the first thing we're going to need is that Nios II processor. So we'll go ahead and add that in. And if you're using the light version, you'll need the /E. I've got a licensed version, so I'm going to go ahead and just use the /F. Gives me a little bit more speed. So that's the first component we need. And then, like always, we need that JTAG UART. So we will add that JTAG UART in. I'll just take the defaults on that. And then we need the SDRAM controller. Now, it's the SDRAM controller Intel FPGA IP. Like I said, in the latest version, this has been removed. You can either run an older version of FreeRTOS to get this, or you can install an older version and pull this IP forward, which is what I did. So I'm going to go ahead and click on that, and we'll add it. Now, there's several things we have to set in order to use this board. The first is our bit width is 16. We have one chip select and 4 banks. That's all good. But we have 13 rows and 10 columns, which will give us 64 megabytes of RAM. The generic memory model for simulation can be checked or unchecked. I'm not planning on simulating, so it really doesn't matter. The other thing we got to set is all the timing details for the RAM. And for this one, we have a CAS latency of 3. Our initialization refresh cycles is still 2. The issue refresh, our issue 1 refresh command is 7.8125 microseconds. The next one stays at 100 microseconds. The next one stays there. This one is 15.0, 15.0, 5.4, and then 14. So that is all the timing parameters we need for our memory. I will go ahead and hit finish on that. The other thing we need is under the university program, you're going to see a system and SDRAM clocks for the DE series boards. We also need that component. And for this one, just make sure that the drop down is set for our DE10 standard and that we're at 50 megahertz on both of those. Now we need one additional component for making FreeRTOS work, and that is an interval timer. So we'll go ahead and bring that over, and I'm going to leave this at the defaults. We want it at 1 millisecond. This is going to become the system tick timer for FreeRTOS. So let's go ahead and let's rename some stuff here. I'm going to rename my processor to Nios FreeRTOS. I'll rename my JTAG UART to debug. I'm going to rename my controller to SDRAM. I'm going to rename this to be clocks. And then, very important, this timer has to be renamed all lowercase sys underscore CLK, sys underscore clock. That's because the FreeRTOS port is actually looking for a timer by that name. If you don't do that, you're going to have a lot of work to do in FreeRTOS in order to rename all of that stuff and make it work. You'll probably have a non-functioning system. So the next step is to go ahead and get this wired up. Like always, our debug reset request is going to go up to our clock reset in. And then we're going to wire some things up a little bit differently this time. So our reset's going to go to all of our devices. So we can wire the reset down. But we're not going to use the main clock this time. We're going to use the clock coming from our clocks module. So we see this one right here called sysclock. That's the clock that we're going to wire to all of our peripherals, including our Nios. And then we see this one called reference clock. That one we wire to our actual clock. Alright, so now we can go ahead and wire up some other stuff. Our debug, we just need the data master. For our SDRAM controller, we need both data and instruction. And our interval timer, we just need the data. Next thing to wire up is our interrupts. So I want my sysclock and my debug to be on interrupts, and I want to change the priorities. I want sysclock to be 0 because I want it to be the highest, and we'll move the debug port up to interrupt 1. Okay, the last step we have to do is we need to export some things. The first thing we need to export is in the SDRAM controller. I'm going to call this SDRAM underscore wire. And then under my clocks, the SDRAM clock, we're going to call this SDRAM underscore clock. So we should have 3 signals exported. We have the clock, the SDRAM wire, and the SDRAM clock. So that's pretty much it. We're wired up. At this point, we can do a system assign base addresses and then go into our thing here and assign our vectors to our SDRAM. And we will do a save. All right, we're all saved. And next step, we need to generate some HDL. I'm just going to leave the defaults and hit our generate button. All right, we're all done with that. So I can go ahead and close. I can hit my finish in Platform Designer, and that'll take us back to Quartus, who's going to tell us that we have some new IP. So we will go add in set IP really quick. And as always, we want to go into our project name, synthesis, and we want that quip file. So there we go. Let's go back to hierarchy, and I need to do a quick compile so I can set my pins. All right, our quick compile is done. So now we can go to our assignments and our pin planner. And then I'm just going to scoot this all the way up so we have as much room as we can. And then first things first, we need to change all of our I/O standards to be 3.3 LVTTL. So we'll just go down the list here really quick and assign all of those. All right, all of our I/O standards are set. Now we need to assign our locations. We know our main clock is on AF14. By the way, we can find all of these in the user manual. This one is AH12. And then our addresses starting at 12 is on AJ14. AH13, 10 is on AG12, 9 is AG13, 8 is AH15, 7 is AF15, 6 is AD14, 5 is AC14, AB15, AE14, AG15, AH14, and the last address is AK14. Now we need to worry about our BA1 and BA0 lines. Those are on AJ12 and AF13. So those aren't too bad to worry about. Our CAS inline is AF11. Our CKE is AK13. And our CS underscore not, our chip select not, is AG11. Alright, now we got the DQ lines to do. And our first one of those is AJ5. Then we got AJ6. Then AH7. AH8, AH9, number 10 is AJ9, AJ9, AH10, we've got AJ11, AK11, AG10, AK9, AK8, AK7, AJ7, and AK6. I'm off someplace. Hold on a second. Alright, I figured it out. So the 9 should have been AJ10. The 8 should have been AH10. The 7 is AJ11. This one, 6 is AK11. Then we've got AG10. AK9. AK8. AK7. That's better. AJ7. And our last EQ line is AK6. Alright, so that leaves our DQM, our RAS, and our write enable. That first one's AK12. Then we've got AB13. Then we've got the AE13. And then we've got the AA13. Now there is a much faster way of assigning these. I'm just doing this to illustrate where they all go a little easier. The other way to assign these, you can look for resources from Jurassic and they give you something called a golden top. So if you open a file called the QSF file in your project, you will notice that all of the pin assignments go in here. And you can just go copy the pin assignments from the golden top down to here and then just make sure your names match up with their names. And it will assign all those pins for you. But we're done. We have our pins assigned. Let's go ahead and start that full compilation. And while that's happening, we'll go ahead and we'll start our build tools for Eclipse. All right, let's go ahead and hit browse. We want this to be in the Nios FreeRTOS folder. We're going to make a new folder called software. That's the folder we want to be in. We'll go ahead and hit OK. Alright, here's our build tools for Eclipse. We'll go ahead and maximize that window. And as always, we got to start off with a new application and our VSP from templates. And we'll go grab our SOPC info file. I need to get to the right folder here. We want that Nios FreeRTOS.SOPC info. Okay, we're going to call our project, not that, we'll call it Nios FreeRTOS. And then we're giving ourselves 64 megs of RAM this time, and for FreeRTOS to run, I'm going to go ahead and use that hello world. And I'm just going to go ahead and hit finish here. Alright, and our software projects are created. Like always, I'm just going to start off a build to make sure everything builds okay before I start messing with it. Alright, looks like everything built just fine. So first things first, we need to import FreeRTOS into our folders or into our project. So what I'm going to do here is I'm going to create some new folders in my Nios FreeRTOS. I'm going to give it a name of FreeRTOS. And then under FreeRTOS, I'm going to create a couple more folders. The first one's going to be include. I'm going to go back there. I'm going to create a couple more. I need one called new folder. I need one called portable. And then under portable, I need another new folder, and we'll call this one GCC. And under portable, one more new folder, and we'll call it mem Mang. So that's where our memory manager is going to go. And then under GCC, we need one more folder. New folder. And that we're just going to call Nios II. Alright, so there's our folder structure. The next step would be to go out and download FreeRTOS from the freertos.org website and extract it someplace. I have already done so, and I have it right here. So inside of my FreeRTOS folder, we're going to see a source directory, and then we see an include directory. So I'm going to go into that include directory. I'm just going to hit Control A. I'm going to drag and drop all of those things into my include folder. And I want to make sure it says to copy files. That way, if I link to them and I end up deleting that extracted folder, we would have a problem. So I want to copy them into my project. Alright, now if we look in our include, there are all of our include files. So the next thing we need is in that portable directory. We need to go down to GCC and scroll down till we find the Nios II folder. And we need to grab all three of those and drop them in that Nios II folder. And making sure we do copy. Alright, next we need to go, staying in the portable directory, we need to go down to the memmang folder. And there's several options. We're just going to choose the simplest option, the heap one, for this demo, just because the others take a little bit longer to set up. So we'll just copy that first version of the memory manager in there. Alright, we're almost done. We need to go back to the source, and we need to grab some of these source files really quick. So I'm just going to grab all the .c files. We might not need all of them for what we're doing, but we'll go ahead and bring them in because who knows what you're going to do later with this project. And we'll just drop those on that FreeRTOS folder. Again, making sure we copy. Alright, so that should bring in all of our FreeRTOS stuff. Next step is we need to go up here to our project and go down to properties. Alright, so here's our project properties. In order to make this work right, we need to go down to the Nios II application properties and the Nios II application paths. And we need to add in some include directories. So we're going to hit that add button there, and we're going to go into first, we'll just add our current directory. Yes, I want it relative path. That'll just put a / there. Next, we need to go into that FreeRTOS folder, the include. So we need that one. And then I need the portable and the GCC folder and the Nios II, because there's a header file in there. So those are the three I need to add. So we'll go ahead and hit apply and hit OK. All right, next step, I'm going to open up Hello World. And I'm just going to hit Control A and delete all of that. We're going to open up our system.h as well, because we'll need some stuff out of there. And the last thing I'm going to do, I need to say I need a new header file. We'll put it there, and we're going to call this FreeRTOS config.h. and I just want it to be a blank file. So we'll go ahead and hit none on that. Now, I basically have copied this from one of the samples, and you can do the same. I'm just going to paste that in there. And all this is I've taken out a lot of the comments, but it's just setting up the basic parameters for FreeRTOS. Like are we using preemption? Do we have an idle hook or a tick hook? We don't have either of those. What's our tick rate? All of that good stuff. What API functions we have available. Kernel interrupt service priorities, that sort of stuff is all defined in here. So we need that there. We can go ahead and close that now. Now we need to write some actual code. So let's go to our hello world and let's bring in some libraries. I need to bring in standard.io.h. I need the interrupt stuff. So sys alt irq.h. We need our system.h. We need then we need to bring in a few FreeRTOS things. So let's do a pound include. And since I put the paths in, I can set those as system level, not project. We need FreeRTOS.h, and obviously we're going to write some task, so I need task.h. So those are the basic header files I'm going to need. Let's create a couple of tasks. Void star p. Copy that, we'll call that task 2. They're not going to do much, but we'll need a couple of tasks to show task switching. So we can do that. We're going to need an int main void. So that should be all the functions we need. Let's just say hello from Nios II running FreeRTOS. /n. All right, and then we just need to create a couple tasks. So we'll do an x task create. We'll call this one task 1, or we'll call task 1 function. We'll call it task 1. We'll give it 512, null, priority of 2, and null because I don't care. I'm just going to cut and paste that and change the 1s to a 2. 2. And then let's start the scheduler. vtask start scheduler. And then return 0. So that's main, pretty simple. And then all we're going to do down here, let's just say printf hello, I am task 1, right? And then we'll do a vtask delay. Oh, let's do this one for 5 seconds, not quotes. I want that. So we'll do that one for 5 seconds. I'm going to copy that and paste it down here in task 2. We'll do that one for 10 seconds, so it's twice as long, and we'll change 1 to 2. Oops, to 2. So that is our basic program that we're going to do for this. Oh, one very important thing. It's a task. It shouldn't end, right? So those should be in while one loops. Yeah, that would not be good. Okay, that looks a little better. Let's save that. And then I need to do one more thing before we finish. And that is in my system.h. We need to scroll down. I'm just going to look for enhanced. It's easier. We need to find under the system configuration, you'll see right under that it says Altera Enhanced Interrupt API. The current port of FreeRTOS does not work with the Enhanced Interrupt API. It needs the legacy interrupt API. Now, if you have to change anything in your processor and you have to regenerate your BSP, you're going to have to make sure you remember to come back in and change that as well. And with that, we need to rebuild our BSP project. And then we can rebuild our code project. All right, looks like we built fine. Let's switch back to Quartus. And we are fully compiled, so we can go ahead and bring up our programmer. Let's just do a quick save, then we can do an auto detect. Yes. That should be our soft file. Save that one more time. There's our board. Let's go ahead and program it. Successfully programmed. We didn't hook up any of the peripherals, so everything should pretty much be blank, which it is, so that all looks good. Now we can go back to Eclipse, and we can right-click, and we can do our run as. Let's go to our run configurations, and we want to do a new run configuration. All right, let's give this a name. We'll call this Nios FreeRTOS. Let's go to our target, and we can hit refresh. We'll hit apply, and then we can hit run as soon as that is applied. All right, it's just about ready to go, and there we go. Hello from FreeRTOS. So we should see 2 task 1s show up for every